Hello everyone, my name is Ayush Kumar and today I am going to talk about research methodology, especially focusing on the types of engineering research and approaches to solving meaningful research problems. This presentation is designed to help us understand the diversity of research methods and how structured problem solving techniques can lead to significant advancement in the engineering field. Let's dive in. This presentation has three main parts: the types of engineering research, including descriptive versus analytical, applied versus fundamental, quantitative versus qualitative approaches, the process of identifying and addressing meaningful research problems. Third point, a structured framework for solving problems inspired by George Polya's methodology. Let's start with descriptive a- versus analytical research. Descriptive research is about observing and documenting current states without controlling variable. It uses methods like comparison, correlation, and survey to provide a snapshot of a situation. For example, documenting traffic patterns in a city over a week is descriptive research. On the other hand, analytical research goes deeper using existing data to analyze and evaluate causes or trends critically. If we take the same traffic data and analyze why conjunction occurs at certain times, we are doing analytical research. Some studies combine both these approaches for a holistic view. Next, we have applied and fundamental research. Applied research focuses on solving immediate real-world problems. For instance, developing a new algorithm managing urban traffic is applied research. In contrast, fundamental research is about building knowledge, often without a specific application in mind. It focuses on theories or principles like studying the properties of a new material in physics or math. While we apply research has immediate benefits, fundamental research lays the groundwork for long-term advance. Now, next slide is about quantitative versus qualitative research. Quantitative research deals with numbers and statistical analysis. It uses large representative data sets to draw conclusions. For example, measuring the stress strain behavior of 100 samples of a new material is quantitative research. Qualitative research, on the other hand, explores deeper insight from smaller data sets or non-representative cases. For instance, interviewing engineers about challenges in project management is qualitative. Both methods are valuable depending on whether you are looking for precise measurement or understanding complex phenomena. Now, talking about the key attributes of meaningful research problem. Now, what makes a research problem meaningful? A good problem should challenge existing idea, meet long awaited expectations, or simplify a complex theory. It might also open up new research areas or present practical applications. For example, finding a material that is lightweight yet extremely strong is a meaningful. Researchers should always assess the significance of a problem before committing to it. and impactful problems often lead to the most rewarding results. So, the next slide is about the steps to identify research problems. First, we will start with unresolved questions or problems suggested by supervisors or literature. Second point, we will build on foundational theories or use advancements in related fields. Third point is about engaging actively in discussions, ask questions, and reflect on different perspectives. For instance, a researcher working on renewable energy might discover problems with energy storage by analyzing related studies and advancements. The key is to find a problem that is both relevant and significant. Now, to the next slide, we are finding and solving research problems. Meaningful research problems can come from various sources, such as literature reviews, advancement in tools, or even cross-disciplinary insights. While some problems may seem small, addressing them effectively can lead to significant progress. For example, optimizing an algorithm for faster computation may seem minor but could have widespread application. Researchers should also recognize that even partially solving a problem can yield valuable results and insights. On next slide, we'll talk about George Pólya. George Pólya was a mathematician who developed a structured approach to problem solving. His framework is highly relevant to engineering research as well. It involves four steps. First, understand the problem, devise a plan, execute a plan, reflect on the result. This iterative process helps researchers systematically approach challenge while remaining open to revising their. Now, let us understand the problem. The first step is to understand the problem clearly. Rephrase it into your own words to ensure you grasp its core. Use visual representations like diagram to break it down into manageable parts. For instance, an engineer might sketch out the forces acting on a structure, identify stress points. It's also important to identify any missing information that could be critical for solving the problem. Next, we will see the devising a plan. Once the problem is understood, the next step is to devise a plan. Start with simple strategies and gradually explore more complex approaches. Look for recurring patterns or commonalities that can guide your plan. For example, if you're studying material failure might test its behavior under controlled stress conditions. Before considering combined factors, breaking the problem into smaller parts can also make it easier to tackle. Now we will see how to execute the plan. The third step is to execute the plan. Test your strategy in a real world scenario or through simulation. If it doesn't work, go back, revise, and try it. This iterative process allows you to refine your approach. Taking break during the phase can also help you come back with fresh perspectives of new ideas. For instance, redesigning a prototype after identifying flaws during testing is part of this phase. Now we'll see reflecting on the process. Reflection is a crucial step. After executing your plan, execute what worked and what didn't. Documenting these insights not only helps with your current project but also prepares you for your future research. For example, a researcher might rely that a certain methodology was particularly effective and decide to adopt it for similar problems in the future. Reflection ensures continuous improvement. Talking about the conclusion of our topic, to conclude, engineering research is diverse and requires a clear understanding of its type, from descriptive to analytic, applied to fundamental approaches. Identifying and solving meaningful research problems is a critical skill, and, and what we saw is George Polya's framework provided a structured, effective method for tackling challenges. I hope this presentation has given you a valuable insights into the research process and how to approach it systematically. I would like to thank you for your attention. Thank you.